Hi, I'm Dave Wood. I'm the Technical Director here at Fowler, and this is your Fowler Metrology Minute.
So today I'm going to talk about measuring force, technique, and how that applies to metrology. So the basic idea is everything flexes. Everything in our world is a little bit movable. Everything can bend. Even a giant skyscraper made out of tons and tons of steel, if the wind blows, you're going to feel a little bit of movement up towards the top. So this becomes a problem in metrology because the measurements that we're taking are sensitive enough that we can measure the flex in the tool that we're using to measure our workpiece. So this is error introduced to the system that we don't want. So the unsung hero to get around this problem is measuring force. If we have a nice repeatable measuring force, then we're going to have a little bit of flex when we take our reference measurement, or our zero, and every measurement we take after that is going to have the same amount of flex, and thus will cancel out the initial. So to illustrate that, I've got some Fowler Silvac lifetime warranty tools on the table here. I'll start off with a caliper because this is the most egregious example of user error and flex. So this is a very good caliper, and if your technique is good, you can take very repeatable measurements all day long. However, since the user is supplying the measuring force, a bad technique can introduce a lot of error into the system. So if I push too hard on this, you can see the numbers start to dance around a little bit. So user error, user technique is very important with a hand tool where the user is supplying the measuring force. So moving up in precision a little bit, next is the rapid mic. Now this uses a spring-loaded ratchet in the handle to supply the measuring force. So it's much less user input. Once the desired measuring force is achieved, it just spins. So I can sit here all day and continue turning this ratchet, and the force doesn't get any larger because of this ratchet mechanism. So moving up even higher into the precision level, we've got the Mark 6 indicator, which uses a spring force to take a measurement, and when properly set up, the user's not interfering with this at all, so that is very, very repeatable. And one step higher than that, we've got a V-series height gauge, and this uses a secondary carriage, which you can see I'm pushing against the spring right here. So every reading that takes, it's preloading that internal spring to the same point every time to get a nice repeatable measuring force, so that all this movement out at the end of the probe is canceled out when you take a measurement. And that's today's Metrology Minute.
Question.